This is something that everyone needs to do no matter what strategy that you are pursuing, whether you want to stake 32 Ether yourself to run a validator, whether you want to pool friends and family money to run a validator, or if you want to create a staking pool, you have to do this part. So what we're going to do in this video is set up a server that's going to host a computer, basically, a computer process that's going to run the validator client for Ethereum 2.0. So you're going to, when you stake your Ethereum or stake your Ether, then you need to have this process running on a remote server in order to do this, okay? So we're doing it on a remote server for a few reasons. One is because you want your validator to be on all the time. So you could definitely do this on a home computer if you wanted to, if you have a dedicated home computer, but there are a few things to watch out for. One, your computer needs to be on all the time, and it also needs to be connected to the internet all the time, or else you could face a slashing penalty for your validator. All right. And the other thing is, if you're a sophisticated, system administrator, you're, proficient with like building your own computers and all that kind of stuff, you might be okay doing this on your own home computer. But it needs to be on all the time and be connected to the internet all the time, just so you know that. So you need a backup power supply. You need a backup internet connection probably. So yeah, that's something to think about. So that's the main reason that we're going to do this in the cloud, all right, is because it can run all the time. You don't have to worry about it turning off, all right? The other reason is everyone will use the exact same environment if we do it in the cloud. And so there's no issues of like, hey, this works on my box, it doesn't work on your box, et cetera, et cetera. So this ensures that everyone will use the exact same environment, the exact same tools and everything, okay? So let's go ahead and set this up right now. We're going to use DigitalOcean as the hosting provider for our remote server, okay? So there should be a link in the resources down below where you can sign up for DigitalOcean, all right? You can get a credit for trying this out for free, all right? You'll be able to run this at no cost and try it out, see if it's something you want to do. And yeah, so make sure you click that link to get that free trial. Once you set up your account, go to your dashboard and go ahead and get started creating a new project. So you can do that at a few places. There should be a button up here to say create. Let's see here. Let's actually just start new project. Over here on the left-hand side, you should see a new project here. And we're going to call this ETH2 validator. You can call it whatever you'd like to, but that's what I'll do for now. So let's just say Ethereum 2.0 validator client. And so we'll say node. And it's for, whatever you want to really. Say other. Blockchain. Click create project. All right, so we don't want to move any existing resources in here. We're going to create new ones. We'll say skip for now. And so we're going to get started with the droplet. All right, so let's create that. Basically, the droplet's going to be a virtual machine. So we're running a server in the cloud. So this is just going to be a computer. It's a virtual machine, so we can choose the type of computer that we want. So we want Ubuntu Linux. This will be a Linux box, all right? And we want the basic plan, all right? And then we want to choose our droplet. So we're going to need at least 100 gigabytes of space to run this. This would be the optimal one to choose, but you can run it on this one as well. Okay. Again, you have a free trial for doing this, so you could test this out. You could do the more expensive one or scale it to the smaller one, see which one, changes the performance for you. I'm going to choose this one for now. Okay. So next, actually, I'm going to do it for this in the demo, but you could probably do the 40, you'd be fine. So next, you want to choose your region. I would recommend just choosing one that's close to you. So I'll stick with New York for me. For VPC network, I would just use the default. All right. And then next, what I would do is create a password to access your node or access your virtual machine. So what we're going to do is give you the ability to log into this remotely, okay? And so you can create a password like this. So I'm gonna do mine off screen, and I'll be back in just 1 second. So now that I've finished that, we're just gonna create one droplet. You can, name your host whatever you want to. You can add tags if you want to. I'm gonna skip it. Let's see here. Let's do this. Let's just say ETH2 validator. That'll help me remember it. Validator. Yeah, we'll just call it that. And then you can enable backups if you want to. It will definitely cost you more. I'm going to click yes for now. All right. And then click create new droplet. All right. So now we have a droplet finished, and that's basically our virtual machine. So we have a computer that we can run our client on. The next thing that we want to do is set up a database. Okay. So we have to do that to store data for the validator. And yeah, we need to connect the database to the validator. So basically we're going to have a VM here. So this would be a VM. So our validator. Okay. And then we're going to have a database. Again, the VM is just a computer, and the database is just a place where we store information, okay? And these are all in the same cloud setup, okay? So we have to create two different pieces of technology, but they're going to talk to one another, all right, inside this same hosting account, okay? So we're setting up the validator, all right? That's what we just did. It's a computer, it's a server, and this database is going to exist basically on a different server, and these two servers are going to talk to one another. All right. So let's go ahead and set up the database. It's pretty easy. We'll just go to, let's see here, create manage database. All right, we're going to use Postgres. We'll do we'll just start with the $15 a month plan. Should be fine for now. All right, we're going to choose the New York data center. Use the default VPC network. Okay. We'll call this ETH2 DB. Okay. We'll create a database cluster. You can always scale up your database later if you need to, but we'll choose this one. So this will take a few seconds, so I'll wait for it to finish. If it goes long, I'll edit it out in the video, but it looks like it's moving pretty fast. Okay, so you've created the cluster. All right, so this is really just this instance right here, but now we actually need to create the database inside of it. So it's provisioning. All right, click get started. We want to restrict who can talk to this database. And you want to search for the name of the VM you just created a minute ago. So in this case, it's ETH2 validator. All right. So you might see some different options here. You might see your own local IP address. But the idea is that we don't want anybody, any random computer or person to be able to connect to the database. We want to limit who can talk to it. And in this case, it's going to be the computer that we just set up, this VM here. So basically, we're just saying only you can talk to this database, all right? So allow these inbound sources only. Okay, and then so you want to take these connection details and take them offline. All right, I'm actually going to do this right now. I'm going to show my password. I'm going to copy them and put them in a basically a text document. I'm not going to save it, okay? But I'm going to basically put them in a text document. I just cleared out my password, but I'm going to do it like this and have it for safekeeping because we're going to use those credentials here in a minute, okay? So make sure you save those. It's best to use like a password manager like 1Password or LastPass to save this kind of information. A lot of times those those programs will have ways to store database connections in a secure way. You really don't want to store this in a plain text document somewhere. It's fine if you're just playing around with this on the test network for now, but in production, you definitely don't want to store your database credentials, somewhere that could be exposed, okay, especially if we're running a validator client. So click continue. All right, so we don't need to migrate any existing databases. That should be it. Everything do great. I'm done. All right, now that we have the database set up, let's try to log into our virtual machine to set everything up. Okay, so go back to your projects here on the left-hand side. Click on your project name. So mine's ETH2 Validator. Let's click on this ETH2 Validator setup here. Okay, so like if you ever need to upgrade your droplet, it's pretty easy. You can just how to upgrade, all that kind of stuff. Like I said, what we have here for now should be fine. But let's go to access, okay, because we basically want to log into our box. So you can do this a couple different ways. If you just want fast access, you can do click launch recovery console and then paste in your password that you had earlier. All right, so I'll pull mine up here and let's see here. Hold on a second. I gotta find mine. Let's see here. So yeah, you basically want to take your password and paste it in here. Well, first you actually want to type in the username. So in this case, it'll be root. All right. And then you want to paste in your password here. So you can type it in or you can paste it in. Okay. And that's how you connect to your box without having to use a terminal. You could do everything in your web browser here. But I recommend using a terminal just because it's a lot more flexible. You can have multiple terminal tabs open, multiple connections to the box. You can, get more advanced, more sophisticated. This might work for you, and this might work as a good, maybe emergency login to your node if you need to access it from a different computer or something like that. But for now, I'm going to just kill this. I'm not going to do it in the web browser, but I wanted to show you that so you can see it. But I'm going to show you how to do it from a terminal. So you definitely need, if you're on Mac or Linux, you should have SSH out of the box. On Windows, you may have to do some additional configuration to set that up. But you want to log into your node like this. You want to say SSH root at, then get your IP address here. Okay. So you can see this public IP address. So don't try to SSH into mine. Okay. I'm not gonna, I'm not gonna use this for real in the real world. So don't try to hack into this or anything and steal my ether. It's not gonna work. So anyways, click on that and then click yes. And then you want to put your password in just like you did a minute ago. You either type it in or paste it in. I'm gonna paste it. And boom, there we go. All right, so now we have an SSH connection to our VM. So if you're not sure what SSH is, basically it's just a connection. It stands for secure shell. So basically we create a connection to this computer from our computer with our terminal that's encrypted, okay? And it's basically a secure way to talk to this computer. Basically pretend like we're on this computer from our computer. We can put data over here. We can pull data from here. And we can just have direct access to this from the command line, okay? Because the Linux box, it's a headless computer. There's no monitor. There's no UI or anything like that. We just work on this computer, on our computer, directly through the command line. All right, so now that we're successfully logged into our virtual machine through SSH, we're going to set up our validator client. But before we do that, we need to ensure that you have a few other dependencies, okay, before you can do this. There's a couple other things you need. So let's address some of those. Some of those you might have already, if you've been, following this program and following my YouTube channel for a while. But if you're brand new, that's okay. I want to cover everything. Make sure you don't miss anything. But first, you need an Ethereum wallet. Okay, so I'm using MetaMask for this. All right, so you can just go to the Google Chrome Web Store and find the MetaMask extension for Google Chrome and make sure you install it. Okay, and then go through all the setup steps to get Ethereum wallet. And the next thing you need to do is get some Ether for that wallet. So, like I mentioned before, we're going to do this on a test network for this particular setup just to minimize the liability. You want to do this on a test network first before you go to mainnet, all right? And the setup is basically the exact same with a few different exceptions, like you just changing some settings, okay? So this is one way that we will be different is we're going to use a test network instead of the mainnet. So what you want to do is go to your MetaMask and click on the Goerli test network, okay? And you want to get some test Ether for this. So you can get test Ether from a faucet, which I'll put a link to down in the resources below. So essentially what you do is you get on Twitter, okay? You make a tweet that says, I'm requesting faucet funds into this address, and you actually, paste your MetaMask address here. All right, and then you'll click tweet, and whenever you do, you'll find the tweet, okay, and you'll copy the link. Let's see here. Go here, copy the link, put it back in the faucet. Say give me Ether, and you want it at least 32 Ether. So you need a minimum. You need to choose this one at least. Okay, I recommend going and choosing the highest one, but if you do that, just know that you have to wait 9 days before you can request anymore. Okay, so just click one. So this is not a real social media post with an address in it, but that's the idea. You actually want to go through those steps, click on Give Me Ether, and then once you're finished, you'll see your balance increase here. The next thing that we need access to is an Ethereum 1 node. Okay, so we're setting up an Ethereum 2 validator, which you can see here. We're talking to our database. But we also need a connection to Ethereum 1.0 because right now, we're in the beacon chain phase. So you need to still talk to ETH1. Right, so this is, let's see here. This is ETH2 right here. So we'll just say, ETH2. But our ETH2 validator still has to talk to ETH1 right now during the migration phase, okay? So what we're going to do is get a connection to an ETH1 node here for free. Okay, we're going to use something called Alchemy. So there's a link down below where you can sign up. This is an Ethereum node as a service, so you don't have to run your own ETH1 node yourself. It's pretty cumbersome to do that. It's expensive. It takes a long time, so we're just going to get one out of the box. So click the link down below to sign up for Alchemy to grab your ETH1 node right now. All right, so once you've logged into Alchemy and created your account, we're going to create a new app, okay? So you can go to Apps, go Create App, and we're going to call this ETH2 Validator. So go ahead and fill both these out. And we're going to do, we'll call it Staging Environment for now, and then we're going to click the Goerli Test Network and Create App, okay? So then you'll click on, ETH2 Validator. You'll click View Key, all right? So I'm not going to expose mine on screen right now, but you'll view your key, and that will be the connection for your validator that we're going to pop into our ETH2 validator here momentarily. So just keep this handy. We'll reference this back in just a minute. All right, so now we're going to set up the script for installing Prism. So Prism is going to be basically how we run our validator. Okay, so you can see the minimum system requirements here, the hardware recommendations. We're meeting all these. All right. So you can see here, here's recommendations. Here's the minimum. We've definitely met the minimum here. So I think before when I was showing you the, different tiers of CPU, this is probably the better. This is the higher tier, but the lower tier will definitely get you there. So if you want to make yours more performant, you can pay more per month, but the one that I recommended should satisfy these, okay? So we're going to install Prism like this. We're going to use the Linux steps because that's exactly, what we're running in our virtual machine here. So we'll literally just copy this. So this is going to create a new directory called Prism, and we're going to enter into that directory like this. So now you can see we're inside Prism. And we'll copy this. This is just a script from GitHub. So we'll just paste it in. So curl is just a command that downloads content over the web with Linux. And then here's the GitHub URL for the setup script. So a .sh script is just a bash script that can be run on our terminal. And then basically it gave us permissions to execute this script. So now that we've done that, we can go to these instructions. So click that link here. That'll show us how to set it up. So we've got Prism, okay. Then we need to run the beacon node, all right. And then we will we're going to follow through all these steps, okay. But what we want to do now is actually set up the beacon node. All right, so we've got an ETH1 node, all right. But I'm going to go ahead and take you to a different link here. All right, this is how we set up the Piermont testnet, okay? Because that's what we're going to use. We're going to use this testnet on Ethereum 2.0, and we're going to go through these setup steps to get it. So we've got Prism. Now what we want to do is follow some of these steps in order to actually run the beacon node. So you see we've got this script here, okay, that we can run because we're inside this folder. So we say basically, actually, yeah, let's change directory here. So don't copy this verbatim. We need to exit this Prism directory. Well, let's just leave it in here. So let me show you what this command means. This says from the current directory / run the prism.sh. That should work, okay. And then basically we do beacon chain, and then it wants to give us our Web3 provider to our Ethereum 1.0 node, okay. So basically, you can see here, our validator needs to talk to Ethereum 1.0. That's what you set up with your Alchemy provider. So go find your Alchemy app, all right, and let's see here. Go ahead and click on your E2 validator, click View Key. So I'm going to show mine on screen. It's not the best practice. I'm not going to use this for real, so you guys just don't use my app. Like, I'll probably turn it off after this class anyway. So let's just, sorry, let me turn my phone off here. Let's go ahead and just copy this URL, all right, and then go back to the terminal here, and then let's just backspace this, and then paste in your URL like that, all right. I'll let this run in, okay. So we'll click accept here. All right. So you can see this is syncing. All right, so now our node is syncing, and this is going to take some time, okay? It basically has to catch up before you can continue, and this could take quite a bit of time, okay? So this could take 8 hours. This could take, 16 hours, and it's one of the biggest reasons that I've created, put this part of the masterclass separately, is because, I can't do this live on, and then wait for this to finish. It would just take forever. So you need to wait for this to sync. You need to wait for it to finish. So I'm going to go ahead and pause this for now, and I'll catch you back as soon as mine is done. All right, so I've been syncing my validator. It's almost finished. But before it does, I want to show you something, okay? Because, we've started our validator process here, or our beacon client. I want to say I'll explain the difference between those two things in a minute. I think I may have misspoken earlier when I was talking about some of these things, but I'll clarify everything momentarily. But anyways, you'll notice that if we close our window here, there's a problem, okay? Because if we close our terminal, then this process just stops, and our process this won't be running anymore if we close our window. So I'm going to show you how to run in the background, okay? So we'll go ahead and do that by doing Control C, Okay, right now, go ahead and stop the process. Okay, now it's stopped. I'm going to show you how to run in the background. So we're going to do this with system D. All right, it's a Linux. It comes natively with Linux, and you can start processes with systemctl, which comes with system D, and I'll show you how to do that right now. So I'll put some links to this down in the description below. But here's a basic guide that will kind of explain how systemd works if you want to read more about it. Basically, it lets you start and stop services on a Linux server. That's all it really does. So you can see like, see here, starting and stopping services, like systemctl start, application.service. All right, we can run it in the background, all that kind of stuff. You can stop services. So we're going to create a service file for Prism, and we're going to start it with this. So it's like systemctl start, prism.service, and we can stop it with, systemctl stop prism.service. So in order to do that, we first need to create a file, okay, for Prism. So we'll say cd /etc systemd. I'm going to bump this up so you can see it better. All right, and then systemd, and then system, okay? It'll do ls, so you can see your services inside of here. So you're going to do touch prism.service, okay? So I've already done this, so it's going to fail. I've already created one, but then you can do vim prism.service. So this is going to open it in your text editor, and you're going to import some information here. So yours will be blank whenever you do it, but you can click I, which goes to insert mode, which you can type new text in here. Okay, you couldn't do that before unless you're on insert mode. If you want to read more about Vim, you can just Google that, but basically it lets you just edit files on a server. And you're going to copy this gist right here, the contents of this. You can go to raw, click all, go into your terminal, and then literally just paste it in. All right, what the blank space is. So I've already put mine in here. But essentially, where it says your API key here, you want to replace your actual API key from Alchemy. So I'll just explain what this does. Basically, actually, this shouldn't be in here. Let me just kill this from my file. I think I actually copied the contents of my Scratchpad over there. But anyways, what this does is it's just a file that creates these services. So you have this unit at the top. It has a name, so Prism client, service. So a user is just root. You don't need to change any of this. Working directory is root/Prism. You don't have to change that. Exec start, basically this is the script that gets run whenever you start the service. So basically this just runs that same command that we did a minute ago. So again, make sure you replace your actual API key here. Don't try to use mine because I'll probably turn it off after this masterclass. Restart always, and then here's the install instructions, okay? So you just click escape to exit insert mode, and then hit colon, and then WQ, enter, all right? And then now we need a restart, okay? So we just do this, sudo systemctl, daemon reload, and then we can start the Prism client like this. So we could just say sudo systemctl start prism.sh. Oh, sorry, not prism, it's prism.service. All right. And then we can check on the status like this. Make sure I got the right command because there's a special flag. You can do this. So systemctl-l status prism.service, which is our service name. All right. And you can see it's running. And here's the latest log info. Okay. So yeah, it's starting. We can check on this again. You can check back and see the syncing message, which we'll do momentarily. But you can stop your service like this: systemctl stop prism.service. Okay. So that's what you would do if you want to stop it. I don't want to stop it. I want to keep it syncing, but I can always go back and just check on the status of it with systemctl-status prism service. All right, and so you can see here that it is running, and I'm gonna reduce the size of my font a little bit so it'll actually output everything. And I'm gonna do this. Okay, so I still have about an hour remaining, so I'm going to go ahead and pause the video and come back to this whenever it's finished, and we'll continue setting it up. All right, so now whenever your validator is syncing, you should be able to see it like this. Use this command to look at the status, and you'll see that it's finished applying state transition, and you won't see a countdown anymore, okay? So really, I want to clarify the terminology here. So what we've been doing right now is setting up the beacon node. Okay, so it's a little confusing. Let me just show you right here. So basically, what we've done before, I've talked about, we're setting up a validator, but it's more accurate to say that we've been setting up the beacon node. Okay, so I think of the validator as kind of a single concept, but you have a beacon node. And then you have a validator. Okay, and these are two separate processes on the same machine. Okay, so here's the beacon node, here's the validator, and these are all on, your cloud server. Okay, so we have just finished setting up this. So basically, what this does is it connects your entire setup to ETH1. Okay. So ETH1, that's what we had the Infura set up for, okay? You talk to ETH1 with Infura, and that goes to our beacon node, okay? And this keeps everything, in sync with one another. And then the actual validator is going to talk to this, okay? So this will all be on the same box, same system, but we just have to have two different processes set up. So we set up this process, and now we want to set up this process, which we're going to do right here. Okay, so you can see that in the Prism instructions. Again, there should be links to this down in the description below. But we've got Prism, we've set up the beacon node, that's finished syncing, and now we want to set up Prism. But before we do that, you want to click on this link here and then go through all the steps on the onboarding process for ETH2 Launchpad. Okay, so this will be for the test network. So you can see the Puremont subdomain here. All right, so you're going to go through these. So Ethereum 2.0, it's basically just an explainer to show you what you're doing, okay, to make sure that you accept the terms. So this is going to be all on the test network, so don't worry about it too much, but this is definitely, you want to go through all this on the test network before you go to the main net, just so that you see what the steps are like, because you don't want to do this live in production if you've never done it on test network before. So accepting everything is fine. It's basically just saying you accept the responsibilities, you have slashing risk, you have mnemonic, all that kind of stuff, okay? Signing keys, etc., etc., etc. All right. Early adoption risks, and then confirm. They're basically just saying you understand everything. You know what you're getting into before you do this, okay? So choose your ETH1 client. You want to click Geth. Okay, so we've done that already. Click Continue. We're using Prism, all right? So now we're going to say we have one validator. If you want to run more validators, you definitely can increase that, but for now we're just going to do one. We're using Linux. Okay, so you can download this CLI app. We'll do it from the documentation here. Don't worry about that just yet. You mostly want to worry about getting your validator file ready, okay? So click Continue. All right. Now what we need to do is actually go through those setup steps of downloading the CLI so we can generate the validator keys so that we can upload them here, okay? So we're going to do that from our terminal inside the web server that we set up. So we'll do that like this. I'm going to paste a link to this down in the description below. So you'll have this command. I'm actually going to make it my notes here right now so that I don't forget. So deposit command. You'll see deposit command down there. And then, or actually we'll say download CLI. Okay. So download, actually, I'll tell you what, let's put this in a gist. So I'll do it right now so that you can have it. Let's just do it here. Okay, we'll do that. Let's, I'll show you what I'm doing off screen here. I'll put it in. Okay, so we're gonna basically download it onto our server like this. We're gonna unzip it like this, or decompress it, I should say. We'll move it to the Prism directory, and then we will yeah, that's what we'll do. Okay, so I'm gonna create the gist. So I'll put a link to this gist down in the description below. I'll put it right now. So let's see here. All right, so you can see for generate keys, you'll find this gist down below. So copy this, and then actually edit this. Hold on. This is wget, not get. Okay. So you can go to raw, and then do wget, and then let's just paste exactly what we have here. So this is wget's just a command that lets you download stuff in Linux. So you've downloaded it, and then now we can use tar to decompress it. Okay. And then we'll use mv to move this file to the Prism directory, which is our working directory. All right, now let's go ahead and cd to Prism. Okay. So now we can say ls-l. All right, so now we have that deposit here. Okay. So let's see what the next thing we need to do here is. If you go back to your web browser here and you click back, okay, and then you scroll back down to this place where it says generate deposit keys for the Ethereum Foundation deposit tool. That's what we need to do. Okay, so basically we're just going to copy this from and make sure you're in this Prism directory. So you can cd home/prism. Make sure you're in here, and you want to run this command. Okay, I'm going to do it off screen because I think it's going to log something to the console. Let me just do it off screen first and see what happens. All right, so yeah, off screen it's revealing my mnemonic. So you want to save your mnemonic and back it up. I recommend using something like 1Password or LastPass because you really don't want to save it in plain text, but that's going to be the mnemonic for your wallet for your validator. Okay, so it's going to show you your mnemonic. It's going to ask you how many validators you want to run. I'm just going to click 1 because I'm doing this off screen. And then you want to create a password for your key store file. Okay, so let's see here. Create your password here. So again, you shouldn't see any of this on screen just yet. I'm doing my password off screen. And then next it's going to show you your seed phrase. All right. So again, I'm not going to show the seed phrase on screen. And then make sure you write that down. Again, I recommend backing this up in like 1Password or LastPass. Okay. Then press any key when you're done. And then you want to type in your mnemonic. Okay. Separated by spaces. All right. All right. Okay. All right. So once that's finished, you should see creating your keys. All right. And then you can see that your keys have been saved here to root prism validator keys. Okay. So go ahead and copy this. All right. Because we need to basically show the contents of this file. All right. So now what I'm going to do is say cat and then paste in the path here. Okay. I'm not going to show this on screen because it's going to actually reveal the contents of my validator keys here. So actually, let's see here. Sorry. You want to actually do this. So do cat and then put in this directory, and then you want to actually log the actual file. So what we want to do is log the file right here, the deposit data file, okay? So do deposit data. You can do tab to completion if you want to. Log that file. Okay, I'm not going to show it on screen. I'm going to do it off screen. But you'll see some JSON file. I'll show you right now what it should look like, but I'll kind of edit it so that it's not super visible. Okay. Okay, so I just edited mine. It should look kind of like this. So basically, you see a JSON file that looks like this. There's the public key. There's a bunch of stuff in between. I've just taken it out. But that's the idea. So start with this and end with this. And I have a whole bunch of stuff in the middle, like a whole bunch of extra text in the middle. But anyways, that's what you see on screen, okay? You want to basically copy that, or you want to save it as the same file name. So you can literally just like go to your terminal, or sorry, your text editor, and like literally just do this. Just go File, Save As, all right, and then save it as a new file. And then just call it the same file name that you see here, all right? So like, I'll show you, hold on. So basically, like, find this file and just take this exact same name, copy it, and then copy that as the file name when you save it, okay? So I'll just do that right now. Okay, and then whenever you've done that, click Continue. Then go to this here on the page and select your file. Okay, click Continue. And then now you want to connect your wallet, okay, in order to continue the process. So I'm going to click MetaMask. Okay, it'll take a second to recognize your MetaMask wallet. Again, you want to make sure that you are logged in with your MetaMask. So I'll go ahead and log into mine off screen. And so make sure you select MetaMask, and you'll see your account here, and you'll see the ETH available. Okay, we'll click Continue. All right, so now here I want to make a quick mention. This is kind of a bit of a fork in the road. Okay, so it depends on what strategy that you want to do. So again, there's 3 different ways to do this. There is staking with your own funds, like if you have 32 Ether. All right, pooling Ether. This is like friends and family. And then also using a staking contract. So the steps I'm about to show you will work for these 2 different strategies, okay? So basically, in this strategy, you need to control a wallet with 32 ETH in it. Again, this is the test networks. This is all just test Ether, so you can definitely do this. But if you're going to pool funds with the friends and family, it all needs to go in the same wallet before you onboard the validator, okay? But if you're going to do a staking contract, then there will be separate instructions for this. So there's going to be a separate video for how to make the staking contract work with your validator, okay? But essentially what we're doing here is sending Ether to the deposit contract. There'll be different instructions for that in the separate video for staking contract. So if you're watching this video and this is what you want to do, make sure you follow those instructions instead of what I'm about to show you, or else you'll have to start the whole process over again, wait for your node to sync, all that kind of stuff, okay? So, yeah, you only want to continue these steps if you have 32 ETH in your wallet, you want to stake it yourself, or you want to, you have control over a wallet that has friends and family funds inside of it, okay? So, yeah, just want to make sure you understand that before you continue. So you'll just click I accept on all this stuff. All right. And then click continue. Initiate the transaction. Basically, this is going to send the 32 Ether from your MetaMask wallet to the deposit contract. I'm going to up the gas price here just to make it go faster. Click sign. The transaction has started, and we'll wait for this to finish. All right, so now it says the transaction has started, but I saw my MetaMask confirmation come up. So if you click on Etherscan, it's probably finished for you already. You can wait for this to say transaction finished, and you click continue. If you do, all it's going to do is show you a success message. So you can either wait for this to finish, or you can go ahead and move on to the next step, which is basically setting up, I guess we're we lost our artwork here. Basically setting up the actual validator client. Because again, we have the beacon node. And then we have the validator client. Okay, and again, these are different processes on the same server. Okay, so we did this. And we just sent our 32 Ether to the deposit contract. And then now we're setting up, now we need to set up this validator here. This is gonna be a separate process. So we'll go back to this here. So again, we've completed this onboarding process with E2 Launchpad. Now we wanna import the validator keys into Prism. So let's copy this, all right? And then go back to our terminal here. And what we want to do is find this directory. So basically, like if you look at what we copied, you see this prism.sh validator accounts import keys directory. So home ETH2 deposit contract -- Puremont. Let's see. We may need to actually update our directory manually, but let's just give it a try. No, it works. Okay, so we were in the correct directory. So we need to enter a wallet directory. We'll just do the default. All right, and then we need to create a password here. So I'll do that off screen. This should be a different password than the one you did earlier. And so actually I had an issue there. So it says could not import accounts for the validator keys. So we need to redo that. So let's do like this. So validator counts import. Let's just change this directory. So we'll do and change this to Prism. Okay, so this should work. And I realized I just wasn't showing you this on screen. So this is what I changed. So this was the failure. I could not import accounts. And then, so instead of doing this directory right here, this ETH2 validators, I did, let's see here, this directory right here. So home, Prism, validator keys import. So you'll want to do your new password. All right, and there you go. It's finished. So at this point, we need to run our validator, okay? So you can see that step 6. So we're gonna do this script right here, but we're gonna do it with launched. So or system D, sorry. So basically, if we're gonna edit that, or we're gonna create a new file like we did earlier. So do cd system or etc system system. All right, so change directory to /etc system D system. So I'll just make this bigger so you can see it. All right, and then ls, and then let's do cat. Let's see, prism.service. Okay, so we're going to copy this, and we're going to create a new file here. So as a touch validator.service. All right, we're going to do vim validator.service. Click I. That's going to put you in insert mode. Paste in this. So we're going to say validator client. And then service root, working directory root prism. So as for the start command, we're going to edit this. So there's Vim commands where you can move around faster, but if you're a beginner with Vim, it's probably easiest to just use the arrow keys to navigate everything, right? You can't point and click out of the box with Vim. So basically just backspace all this stuff until you get here. So prism.sh, and then we want to change this to validator -- Piermont. Okay. And then, yeah, escape :WQ. That updates your file in Vim. Okay. And then, just like I showed you before, whenever you're done, let's see here. We need to reload like this. So sudo systemctl daemon restart or reload. Okay. And then, let's see. We can do sudo systemctl start -l, and we can say validator. Actually, no, just start, not -l. All right, and then we can check on the status like this. We can say systemctl -l status. That's where the -l is coming from. Validator.service. Okay, so we got a little issue here. Let's just fix this. And so I realize what's happened here. Basically, it's trying to read our wallet password, and it doesn't know what it is. So let's go ahead and create a file for that. Let's just do touch. We'll just call it password. Actually, let's not do it here. Let's do touch home / prism password.txt. All right. So we can do vim home / prism password.txt. All right. Then you can do insert, and then you want to actually type your password in off screen. I'm not going to show it to you here. And then you'll save it to that file. Whenever you finish typing it, hit escape :WQ to save the file, and you can, cat your password here, or you can do vim. I would do vim so it doesn't log it to the standard output. But yeah, you can just make sure it works. But then let's go edit our file here. So let's do this. Let's do vim validator.service. All right. Hit insert, and then we're going to enter a new argument here. We're going to call it, let's see here, wallet password file. All right, so I'm going to save this. Put it here. So wallet password file. Okay. And then we're going to do /root /prism /prism, or sorry, that password.txt. And then, yeah, escape :WQ. And then let's reload. Yep, do this sudo systemctl daemon reload, and then sudo systemctl start validator.service, and then we'll do systemctl -l status validator.service, and hopefully it's working. Okay, there we go. Yep, it's working. So now you can see the message here. We're waiting for the deposit to be observed by the beacon node. All right. So what's going to happen here is you have to wait for your validator assignment, and this will take some time. So this could take 5 to 12 hours. So this is something you want to wait for to finish. Basically, ETH2 nodes have to just process your deposit. Okay. So you can basically check on the status of your validator by looking at this like beaconchain.io. All right, so let's go here. This is from mainnet. Let's look at the test network. So let's try Petermont.beaconchain.io. All right, so change the address here. And then, so what you can do here is check on the status of your validator. You can basically take that deposit data JSON file that we downloaded earlier and find the public key, all right, and then copy it and then paste it inside of here. And you can see, let's see here, I think I did it wrong. Let me just try it again. Copy it, public key, put it inside here. Okay, so this should work. Give me 1 second. Let me just see. Okay, so here you can see it. So here's the validator information, and you can see the status here. It's deposited, it's pending. What you have to do is wait for this to turn activated before your validator's live and it's working. Okay. But once you do, it'll be totally active. And so there you go. That's pretty much it. You just have to wait for this to finish to where you're active, and then your ETH2 validator will be live. All right, you will have started staking your ETH. Okay, so as always, remember you want to go through this on the test network before you try it on the mainnet. Again, at the time of recording this video, we're in phase 0, so you cannot currently withdraw your ETH. So this is a one-way street. All right. And, we'll have to wait until we get out of this phase before you can learn how to withdraw it. Okay. Again, this is one way deposit, but this is how you deposit it. And this is how you activate your validator. Okay. So, in the next section, I'm going to talk about how to do this with the staking contract. Okay. So you follow these exact instructions if you wanted to do the, friends and family strategy, or the if you want to run your own validator, you would follow these exact instructions. But the next video, I'm going to talk about how to do it with the staking contract. Okay. And the last thing I'll say is that if you're going to do this with the mainnet, again, as always, do it on the testnet first, but it's basically the same steps. Okay. So basically it's the same steps, but you just change the flags. So wherever you see, dash, Piermont in the descriptions, right? Anytime you see these Piermont here, you want to just change it to mainnet as the network. And, when you're using the block explorer tools, you want to use the mainnet versions. When you send Ether, you send the Ether versions, okay? Or the mainnet version. So it's basically the exact same for the mainnet. It's just that you want to change a few arguments, okay? So last thing is I want to make a quick correction about something that I got a little bit wrong when I was explaining some of the concepts here. So I want to cover that up really quickly. All right, so earlier when I was explaining this, I was talking about the server, all right, and the database. All right. And how basically we were going to run our validator on this, server, and then talk to a database all inside the same cloud provider. Okay, so this is still true. It's just a little bit wrong. So I want to make a correction here. Okay, so basically, we have our validator. Okay, it really looks like a better analogy looks like this. Okay, so we have our cloud instance on the same box is basically a remote Linux server. And this has two processes. The validator and then the beacon node. Okay, so these are two separate processes running on the same thing. And then really inside this same box is the database. Okay, so the database is just written to disk, okay, on this. So we don't actually need to set up a separate database instance in order to manage the data. The reason I got this wrong is because I've set up validator clients in multiple different blockchain protocols, you know, like Chainlink, all that other stuff. And some of them do use databases. And so I've gone through that setup process so many times. And that's one reason I set that up and got that slightly wrong. But I realized it as soon as I did it. And so I want to issue this correction at the end of the video. So you don't need an external database in order to do this. Again, the validator writes its data in the database, quote unquote, the disk. Okay, so you can just go here and just click destroy this database. Don't destroy your validator, okay, because you need that, but destroy this database if you set one up in that database cluster, because you don't need it for this, okay? Because it writes the data to disk, not the actual database. So my apologies that I got that slightly wrong at the beginning of this video. Hopefully it shouldn't cost you too much time, too much headache. It's pretty easy to fix, okay? So that's the correction, and I'll catch you in the next video. Is that, you know, multiple people can deposit Ether into this smart contract, and it can be migrated to the beacon chain to run an Ethereum validator, okay? So I'm going to show you how to do that in this video. So you can do this one of the two ways. You can just deploy the contract itself, or you can get this full